Okay, so let's carry on with a bit of OSPF. So where we are at the moment is I've now configured MD5 authentication between P1 and P2 on the OSPF neighborship. So what we're going to do, we're going to show you how we can do it between P1 to P3, and then we'll do again P3, P4, and we'll do P4 back to PE2. So we can have all four of our PEs have their OSPF authenticated via MD5 hash, and then what we'll do after that, we will do the core to the other PEs, and we'll do that as just a simple password. So we'll have full authentication going on our OSPF area 0. Okay, let's get cracking with that and see what we can do. Alright, so let's jump on to PE1 now. So let's do set CLI logical system PE1, and we're going to do the link between PEs 1 and PEs 3. So let's go into configuration mode, and let's do set protocols OSPF interface, also area 0 interface, and it's going to be LT, and it's .13, and we're going to do authentication, and if we use a question mark we can do simple password.md5, so we'll do md5, and now it's going to ask us for a key ID, so we'll just put the key ID as 1, and now it's going to ask us, do we want to enter a key or do we want to put a start time? So we're going to type key, and then we put in whatever we want for our key. In this case I'll just do 1 2 3 4 5 6, press enter, and if I commit that now, well, let's do a quick run show OSPF neighbor. Okay, so we have our neighborship with router 3, so let's commit. Okay, so what's going to happen here is the neighborship will probably still be up for a bit because it needs to wait for the dead timer to run down. See, so the dead timer for 10, 10, 13, 3 is currently sitting at 30 seconds. And now it's at 20. So we give it a few moments, well, 20 seconds, and the neighborship should actually drop. So we're now at 11. It can be quite frustrating waiting for timers to move down. Oh, 3 seconds. That's probably about right. There you go. Okay, so the neighborship has dropped now because we're sending OSPF packets from PE1 that were authenticated with an MD5 hash, but of course PE3 doesn't have the same on its configuration. So let's jump on to PE3. So let's do set CLI, set CLI Logical Systems PE3, show OSPF neighbor. Okay, that's fine. So we've only got a neighborship between routers 4 and P4 in the core. Okay, so again, configuration mode, and let's do set protocols OSPF area 0 interface LT, and the interface was 31. Okay, so 31 authentication, and we're going to choose MD5 key number 1, and the key is going to be 1 2 3 4 5 6. Commit, and let's do a run show SPF neighbor. And as we can see, we now have the neighborship between PE3 and PE1 is now back up, and it's fully secured via MD5 authentication. So let's do the same now for routers, well, PE4. So let's do set protocols, OSPF, area 0, interface LT, so it should be 34, authentication, MD5, key number 1, and the key is going to be 1, 2, 3, 4, 5, 6. Commit and quit. Okay, now let's do set CLI, Logical Systems, PE4. Again, we had 3 neighborships. We might still have the 3 while the dead time is going down. So show OSPF neighbor. Okay, as you see, the dead time up to P3 is already only at 11 seconds. Now it's at 5 and 1, and now the neighborship has dropped. Okay, fantastic. So let's go along and configure this then. So configuration mode, and you notice that all of these configurations that we're doing within the actual logical system itself, there are, as we've already explained, some things that we need to do in the global instance, but when it comes to routing protocols, etc., we can do all of these literally within the logical system itself. So let's do set protocols, OSPF, area 0, interface LT, and that would be 43, so P4 to P3, authentication, MD5, key number 1, and the key will be 1, 2, 3, 4, 5, 6, commit, and let's do a run show OSPF neighbor. And there we go, we now have our neighborship to 10.10.34.3. So we're back up and running again. Fantastic. And let's secure now the neighborship between PE4 and PE2. So let's do set protocols, OSPF, area 0, interface LT, so it would be 42, so PE4 to 2, authentication MD5, key number 1, key will be 1, 2, 3, 4, 5, 6, commit and quit, and let's move over to PE2 now. So set protocols, it's not set protocols, set CLI, logical system PE2, and let's do show OSPF neighbor. Okay, so we've got 16 seconds before it dies death. Give it a few moments just to make sure it does go down. 3 seconds, and there you go. So it's now dropped. So let's authenticate this peering. So configure, set protocols, OSPF, area 0, interface LT, so it's 24, and authentication is MD5, and it's key number 1 that we're going to use, and the key will be 1, 2, 3, 4, 5, 6. Fantastic. And let's commit that. Let's have a look, see if neighborships come up. Excellent, so the neighborship has come up. Let's see if we can still got ping reachability. Let's do 4.4.4.4, loop back this directly connected neighbor. Yes, we have. Let's do 3.3.3.3. Fantastic. Okay, awesome sauce. Alright, so where we've got up to so far then is that we now have all of these links. So we've got P1, P2, P4, P3. All of these have MD5 authentication securing their OSPF. That's absolutely brilliant. So in the next video, what we'll do is that we'll have a look at these links here to the core, and we'll authenticate them using just simple passwords rather than MD5, just to show that you can run multiple different types of authentication at the same time. Okay, brilliant. So look forward to seeing you in the next video.